happened, but you know what? They didn't get it, which should have never happened to begin with, you know?
Yeah, I'm listening to channel 19.
There's no winners. There's no winners.
People talking politics at that, you know, over the CV. Of course, Democrating, Cheapers, tongue-tied. Talking about Democrats for the most part. Anyway, the band was quiet, and I was just showing the operation of this Tram D201A with the gray and the fixed bias. This is not mine. It's one of the last of a customer's, so we spent a little time to get it out the way, you know, trying to get all the customers out the way so we can, you know, concentrate on my own stuff. So anyway, it was fairly nice. Looks very good underneath. You know, on the bottom, I would say excellent condition underneath. It's been recapped, went through, calibrated, had a few bad parts replaced. Most of the power resistors were replaced, especially to 2 watts, and the power resistors on top of the boards, which is, you know, where the problem is, because the resistors on top are next to the tubes on a circuit board, you know, with no fan or no cooling on it, and that's where all the heat is. If you notice, the resistors underneath, these are original factory carbon resistors here for the most part. They run cool. They're underneath, you know, where the cool area is, and they're not up to up next to a big hot tube. So usually underneath you're cool, and on top you're hot, I guess, literally. So this has been recapped. You can see the electrolytics there, and it's been redone, calibrated, some bad parts replaced. If you see the ones with that pot here on the B audio board, that's part of the fixed bias circuitry there, and that's factory. That's not a mod. That's the latest version. The fixed bias, this version had more mod, but it wasn't considered as stable as the old variable bias version of this. And this is the front. Not too bad, you know, not perfect. And then underneath on the top side, it's good. It's not great. It's not mint. You know, it looks like it had a little bit of moisture, you know, probably, you know, sitting on this top for years that, you know, got through, but, you know, cleaned up pretty well. That's the gray channel selector. And with Tram D201As, which are the 40 channels, the gray selector is good. That's the improved one that worked. And the original black one is the bad one that they had a lot of problems with it. The black ones, if they're not too far worn out and the internal pins aren't too far worn and bent up, they can be repaired. But if it's really bad and the, you know, internal pins and contacts are bent up and scorched and worn out, then, you know, forget about it. But the gray here was the Tram factory replacement repair for that. The grays worked good. There was a better contact in there. That's the channel selector that switches between all these crystals. Tram, I think, is the only radio, or only tube radio I know of, that when they went to 40 channel SSB, that still use crystals. So that's all the most of the crystals used in a Tram D201A. The 23 channel used a smaller board that went along here for the crystal blank, and of course with 23 channels instead of 40, it had almost half the crystals that this one uses. Tram also uses a couple crystals there on the balance modulator or SSB board there. And Trams are not that hard to work on if you know what you're doing with them. you know, for the most part, you know, the boards are marked, you know, what they are and what they do. The Tram book is really, really good. But this is basically the B board here with those 4 tubes on it. And it's also considered the audio board, because that's the audio final, that big tube there. And these are the 3 pre-driver and driver and audio tubes. 2 are combined for the receive and transmit, and then 1 extra preamp for the transmit. So if you got no audio at all, you know, out the speaker, no hiss, no sound, no nothing at all, it's probably something on the audio board there. Also, you got this BA board, sub board, sitting next to the hot tube. Many people think that's a mistake to put, you know, a board like that sitting to the hot tube, but why I think they did that, it makes like a oven. If you see some high-end devices where they need real accuracy, they'll have, you know, the stuff in an oven so the temperature is controlled. It's always hot. And this board also have the low voltage power supply stuff on it, and the low voltage power supply runs to crystals, you know, so it has to be very accurate. If that low voltage is floating around, your crystal frequency is going to run around. So I think they put that low voltage power supply right next to the tube, because it's sort of a makeshift crystal oven. It's always hot. But Tram never, you know, made this radio to run, you know, 20, 30, 50 years. And, you know, over time, having that circuit board with those components on it next to that tube is going to burn it up over time. But, you know, for, you know, 5-10 years, it's not a bad design using it as a crystal oven like that. One of the things you can do if you want to mod one, but, you know, I tried to keep this one factory or close to it, is you can take the components off that board and mount them somewhere else, you know, away from that hot tube, but then you lose the crystal oven effect. You know, transformer, couple can caps there. That black one has been replaced. That was an original silver one, and that smaller silver one is actually there for cosmetics. It's not being used. It's been replaced with smaller caps all across the board. Like, if I want to zoom in, like that one there, I think that one's original, but I think this one here is not. I think that was one that is actually a replacement for one of the big ones. That included, that silver can was actually 4 caps in 1 can. And again, that one is not in use. It's been just there for cosmetics to keep the looks of it, but it's been replaced with like 4 of these across the circuitry right directly to the board, instead of using the old can cap. And anyway, that's your audio board. This here crystal board, basically all it does, all that, you know, your crystal switching, your VFO comes in there, is to put 20 megahertz signal for the right channel, like 20 for channel, you know, 1, and 20.0, you know, 15 for channel 2, etc., etc., out of that RCA jack. That's all that board does. You know, it mixes a 16 megahertz crystal, which is all of these here, or a 4 megahertz and a 4 megahertz crystal down there. It adds them together. One of these and one of these control which channel you're on. You know, and 16 plus 4 is 20. They add up when you mix a crystal together, and you got 20 megahertz at about 5 volts coming out of that RCA jack. That's all that board does. So if you get a frequency counter or a scope and you got 20 megahertz, you know, at the appropriate channel at 5 volts coming out of that, you're good. On the VFO, instead of running one of those 4 megahertz crystals there, it actually switches to 4 megahertz coming from the VFO circuit over here. So the VFO, when you go to it, it puts 4 megahertz coming in at that bottom one, instead of going to one of those 4 megahertz crystals. So when you go to VFO, you got 4 megahertz, you know, at the bottom there, with one of these 16 megahertz crystals here, And actually it hooks to the channel 9 crystal if you do it per the factory way. But there's an alternative way where if you just hook it to any one of these, where you can use the channel selector to switch them. You know, channel 9 you would be on frequency. You know, channel 1 you would be like 10 channels below, and channel 40 you would be like 31 or so channels above channel 9. So you would get more range out of your VFO if you hooked it up that way, but it would only be accurate on channel 9. And by the way, this one is hooked up that way. I didn't do that, but it was already that way, so we left it. But anyway, whether you're on the VFO or not, all you're getting out of this is 20 megahertz out of there at 5 volt. You check that, you got 20 megahertz, you're good. You got the balanced modulator or SSB board that does a lot of SSB work. It does a little bit of AM work, but mostly it's for SSB, and it does a 6 megahertz. Because again, this one is your 20 megahertz, and then that one puts out a 6 megahertz with one of those two crystals. One of them's for AM, I think LSB, and one of them's for USB. So it does have a 6 megahertz coming out of that, and 20 megahertz plus the 6 gives you your 27 megahertz. But that's what that board does, is basically your SSB stuff and your 6 megahertz. That's your transmit driver tube, the small, and the final tube there. And over here is the receive board, AM and SSB receive. It's on that big board there. So if you kind of know, you know, what they do, you kind of know where to look at, you know, whatever your problem is on this Tram D201. It does have a pretty complicated, like a 6-pole, 110 volt relay that's kind of hard to find. Those cost about $50 when you can find them, so you know, try not to blow your relay. But anyway, I didn't mean to get into it. I was just really showing that this radio is ready for a customer. There's nobody on the band earlier. There was skip running earlier, but anyway, it receives really good. You know, I have a big noise level at my QTH, while you hear all that noise and static. I did have a lot of people ask, they'll see on the Tram, you see that little basically red thing sticking there with a black band? That's a small switching diode. And that's for the VFO. And from the factory, it uses that diode to not run the VFO during transmit. The VFO is for receive only from factory. It's probably illegal, you know, from the FCC to have a radio that you can transmit off the VFO from factory. And a lot of trams you'll see that diode cut. It's necessary to either cut it or take it completely out of circuit to get the VFO to transmit on the VFO. So if you see that, leave it alone. That enables the VFO to be transmit on, which, you know, this one has been done. It's a couple more things to it, but a lot of times, you know, they get a radio and they see a diode sticking like that. They like, what's happening? You know, you mud duck, why you cut that and leave that like that? That's mud ducky. One reason to leave it in, if somebody wants it completely stock, completely back to factory, all they would have to do is push that diode back on and solder it back on, you know, to make it back to factory. So that's why they leave the diode in there instead of cutting it back out. So anyway, that's what it looks like underneath. And we are going to transmit on this thing pretty quick. Hopefully we're just still hooked up. We're on channel 20 crystal. I'm going to turn the audio. Well, I'll leave the audio up for a second. It's still keen a little bit under 3. It actually does 4, but I got it going through a lot of stuff, which is sucking down the watts a little bit. A couple switch boxes, frequency counter, watt meter. And audio, that's average. Audio, like I say, that fixed bias swings a lot. Audio, that is on average. And we're going to put it on peak. Audio, that's peak watts. And then this is calibrated to a bird. Put it on a 200 watt scale. Audio. Swinging about 25, might hit 30 watts. Audio on peak. Hello. So a lot of swing with this thing, you know, from 4 to 30 on peak. Get the volume down. Look like somebody's trying to talk to me. Ain't talking to me.
I've had it on since 12:30 Friday afternoon. Yeah, man, that doggone radio sounded GOOD, man.
That's a local there talking skip sound like.
It's got it holds 10 crystals, but I've only got 1, 2, 3. I've got 7 crystals in it. I don't know if I've come across 3 more channels. I'm going to put channel 3 in here. Yeah, you got channel 11 in there. Channel 9, 10, 11, 18, 20, 21, and 22. Oh, okay. Doggone, now all you need is 28. You know them skip channels there, Roger? I need channel 3, I need channel 6, and I need channel 23, and I got just enough room. All I gotta do is find the crystals that break. Yeah, I heard that. I did. Well, you sounded real good down there in the swamp. I just thought you ought to know. I appreciate it. Yeah, she wet now. She real wet there, are you? Yeah, she won't lie to you too. She's wet, she's ready.
Oh, geez. Okay. We're going to leave that alone. And that's what the original speaker, the tone would be a lot better and a lot more rich if we put a bigger, you know, external speaker on it like that one I use. But, you know, what you're hearing now is just the radio. No tricks, no fuss, no muss. And we're going to do frequency again. We're going to put it on the VFO and go to channel 9. And again, the VFO should be accurate if we are on 9. So let's go to channel, I don't know, let's go to channel 22 on the VFO. There, which is 225, channel 9. And 27.224. Tweak the VFO a little bit. 2249, just about 225. And like I say, we can transmit on the VFO. We're on the VFO now, and it's accurate. But if you go off channel 9, like you go to channel 1 now, see we're down 10 channels, 27.125 on channel 1. If we go up to 40 here, we're at 525. So that gives the VFO more range. We're, you know, 30 above there. And the VFO from the factory already goes from basically about 3 channels below 1. And I think it goes up to about 58. 45, 50, 55, no, about 56 right there before this one stops. But with that added range, because of the crystal selection, it'll go up to about 70 if it'll go that far. Let's see. Yeah, 27.85. But I'm down to half a watt because Tram D201s are not made to be broadband. We would have to loosen some coils and do some retuning to make it broadband, which is basically, to me, kind of ruin the great receive of this tight radio. But that's it for this one. SSB works, everything works. A very nice, not perfect, but nice Tram D201A with the gray selector. Not the last one, but one of the last that I'm gonna do, and then we're gonna, you know, work on my own stuff, and gonna pack this one up and get it ready to ship. Okay, that's it for this one. Bye.